What's up guys, Shawnthebro here, and today we're going to be going over visual effects, particle emitters, however you want to call it. Basically effects that occur when we hit our opponent with an attack. Or really, you can use them for anything. You can use them while attacks occur. So if you have a special effect that plays when you start an attack or a command, you can use them during your entrances, during transitional states, whatever you'd like. Basically, it's going to look like this. And so I have attacks that occur at the hit location when receiving damage, and effects that occur at the block location, the hit location, during a block. So you can see the block is orange, successful block, and the hit is blue. It does actually change with where you hit them, so the lower I am, the lower the particle emitter actually spawns, or the particle system actually spawns. I can even hit them higher, and you can see it pops higher up on their body. So there you go. And now you can tell that they are rendering behind the character. So I've been teasing something for a while now with this HUD, trying to make the HUD render behind the character, make the character's render in front of it. And also we are going to want to add the particle effects, the hit effects, and the hitboxes to being rendered in front of the character. And so shout out to RCO who gave me a good option for the hitboxes and the hurt boxes. So anyway guys, let's get into this today. Let's make some basic effects that are going to make our game look a whole lot different and a whole lot nicer. It's little things, but they really do add up and make a huge difference. So if we go into our code, and before we get started today, let me just say this is episode 91. So we've been doing this series for quite a bit. We have an episode every Sunday, and we're making good progress in the series. So if you'd like to catch up and check out everything we've done so far, or where we come from and where we're at now, then feel free to click this link. It's the icon in the top right corner to go to the Fighting Game Tutorial Series playlist. Otherwise, I'll link you to this video right here, which is very simple. It's just about sound effects, just to go along with the visual effects. We are going to update our functions and events that call sounds so that we can also add visual effects, but there's still a lot of sound effects that are going to go untouched. All right. And with that, let's get started. So first things first, what we're going to want to do is go into our code and go into our base character. For me, it's a fighter template character. Going to scroll down, and we're going to make a blueprint implementable event. You could just make a regular function if you want. However, I much prefer dealing with particle systems and all these sort of hit effects and sound effects in the blueprints. Blueprints have a good way of handling them, so I prefer just using them most of the time. So I had two functions here. I have a play damage effects and a play block effects. Now in the past, if you've been following the series directly, I will have had a play damage sound effects, but I've replaced that with just play damage effects. I'm going to play the sounds and the visual effects at the same time, or from the same call. They can be separate, but these are specifically the hit effects and the block effects. Of course, effort sounds or sounds tied to moves or different states, then you can call them wherever you need them. But in this case, we need it when the collision occurs anyway, so we might as well combine them into one and perform them at the same time. So again, if you've been following the series, I changed play damage sound effects to play damage effects. They are both blueprint implementable events. This one that already was here, and the play block effects, which is new. And then they both have an input parameter of an F vector. So an F vector is basically just a vector that has three values in it that we can use for, whatever we need that matches that type. Usually location, scale, that sort of thing. And so we're passing in the hit location. We're going to determine where our hitbox collided with the enemy's hurt box and get a general idea. We're not going to be super specific. We're just going to know the hit point And then we're going to use that location to know where to play the effect. Of course, it doesn't matter for the sound effect, but it will matter for both of the visual effects, or any visual effects that require us to spawn it where the player was hit. And these are blueprint implementable events. So what that actually means is we don't actually fill out any logic in the code, but we can call it from the code. So back in our fighter template character, you can scroll down to our take damage function. And this is where we were previously calling the start damage sound effects, which we're still accurate. We still want to do that. But what we're going to do now is, first of all, change it from sound effects to just play damage effects. Just change the name. And we're going to pass in a hit location. Well, we don't have a hit location from take damage yet. So if you find your take damage function in the header and look at our parameter list, it's getting pretty tall, pretty long here. So if I scroll over and take damage, we now have a F vector hit location. That hit location is, of course, where the user took damage. So add that to your take damage function, and then in the CPP, make sure you add it here as well. And then pass it in to play damage effects. Only do this one when the character does not successfully block. So I have this comment here. Character did not block or crouch block. You could also do air blocking and make sure that if it fails there, also goes into this. And then the else, if they were able to successfully block, then we want to play the block effects instead, but we still pass in the same hit location. We're going to determine the hit location as soon as the collision occurs in the hitbox actor BP. And so it'll have the correct location regardless of if it's a block or a standard hit. All right. So now we can go back into the editor, and there's a few things we're going to change actually to clean this up a bit. First thing, I'm going to go into the animation blueprint. It's not actually related to the effects, but something that'll make this look a lot nicer. In fighting games, you realize when someone takes damage, there is that little bit of hit stop that stops time, and we have that functioning. However, that actually, usually the character goes into their hit reaction state first. And what I mean by that is if I play this, so I'm going to change this value, and then I'll explain what it means after. All right, so if I play our game,
ready, fight.
All right, and I approach my opponent. When I hit them, you could see that there was no sort of hit reaction because our animations were too long, right? But think about what's actually going on here. We're hitting them, and it is doing hit stop, and by the time the hit stop is done, the blend just says, oh, I've started blending to this state, and now I'm going away. Well, we've only set the hit stop, the hit stun duration on this attack to be about 8 frames, I believe it is. So if I made this 800 frames, so actually let's just make it 80. Wait, we don't need to be that dramatic. This hit stop should encompass that, and we should have hit stun for 80 frames, or just over a second. You can see that the mutant does go into the animation, and correctly. However, look at how the order of operations happens here. A hit connects, the particle effect plays, the hit stop occurs, and then the mutant goes into the hit reaction animation. That's not really what we want. However, since this is happening like on the frame where a collision occurs, and that's when the hit stun occurs, this blend setting, these blend settings for this transition from idle to hit reaction, or really any of your states to the hit reaction, it's trying to blend within 0.2 seconds is what this stands for. And so this 0.2 here is actually going to kind of delay this. If we make this 0.0, and if we were to play this again one more time, then you're going to see the mutant actually goes into the hit reaction state before the hit stop plays. or in the middle of it, right? Because you don't want the whole animation to play or anything, but you do want the character to be in that state. Now, the 80 hit stun frames makes this a little bit weird because of the way it tries to calculate the logic when it automatically blends there. So if we change this back to 8 as an example, or actually as the real value, since we don't need 80 frames, and in fact, there's not enough frames for that anyway to play the whole animation. If we try this one more time, I hit my opponent. You can see they go into the state properly. They go in when I hit them, they freeze, and then they come out once the 8 frames are up. Alright? So just a quick little note, if you want to clean this up a bit with your effects, I think it looks nicer to do that, and I thought it was worth mentioning. We are, of course, always improving our animation blueprint system and our animation system as a whole, so you can always change it later, but that's a nice little detail that I thought was useful. So if we go into our hitbox actor, that is something we'll need. We'll also need our base character BP. So I'm going to pull up the hitbox actor BP, and I'm going to pull up the base character BP. So for the base character BP, everything that you'll need is pretty self-explanatory, I believe. However, I've opted to turn hurt boxes off so you can't see them in this episode, so feel free to do that. It might make it a little bit easier to see these effects that we're going to spawn. There's a lot going on when you see the visible hurt boxes, the particle effects, and we don't have render depth yet. Alright. And basically, you're going to have an error in base character BP if you change this event from play damage sound effects to play damage effects, so you might have to delete your event and just search for it again. And then also search for your play block effects. Once you have them both in here, again, it should be pretty simple to see what we're going to be doing here. We're actually going to be doing the same thing for both of these that we did for the sound effects. You can feel free to change this up as you'd like. You could have a different array for block sounds. You could make a sound cue and just pass that into play sound 2D. Whatever you want, doesn't really matter. For me, as an example, I just copied the sound logic for the blocks. And then I'm going to spawn an emitter at the hit location that comes in from each of these events. So the way this works is you just type spawn emitter at location. And we're going to pass in the hit location that we have from this event. Now, as far as this stuff works, just in case you haven't watched the series, all I'm doing here is I have an array of sound cues. So I made a new variable, made it an array, and made it of type sound cue object reference. Right there. Then I've gone and I filled out the default data, so after you compile and save, you'll be able to see the defaults. I've given it 3 sounds. I use the random integer function with a max of 3 since I have 3 elements to get an index of this array and play that sound. Again, that was already explained, but if you didn't watch that episode or if you're just coming for the emitter, just as an additional note, that's how you can do the sound effects. Very, very simple. Now, for the spawn emitter at location, once you pass in the location, you can change the rotation and scale as much as you want. For me, both of my particle effects and my visual effects here are actually, they're not like one-sided. They can be played anywhere and make sense. However, if you do have a one-sided effect, or in this case, if you have an effect that has to face a certain way to make sense, like if you have a block effect and it's like a curved effect, right? That's in the shape of a shield or something. You do want to make it face the correct way. So what I would probably do is just determine if the character is flipped or not, because once you know what side they're blocking from, you'll know what direction to face it. So if you want to change that, you can flip the rotation based on is flipped. You could actually invert the scale as well if you'd like. Whatever method is easier for you. But I put in an arbitrary scale. One thing that I'm thinking about doing is to show the different levels of damage. Like more damage gives off a bigger effect. You could have a scale multiplier or something in here that is calculated based on the damage. But for now, I just put them all to values that I knew were useful. So 0.5 is fine. 0.8 for this one. But once you spawn this node, the spawn emitter at location, and I'll bring in a new one just so you can see it. Literally the only thing you have to do on here besides changing those values that you want is select your emitter template. Very simple. It'll come up with all the ones you have in your project and you can pick them. These are just particle systems. I happen to have them from one of the FX effect templates off the Epic Marketplace. I can link it in the description if you want to check it out. But as long as you have any, they will show up. I believe you have a few by default from starter content. So play your effects for damage and block here. And let's determine how we're going to figure out this hit location. Because right now it's going to be all zeros. Sure, we passed it in here, but we never actually filled it out and take damage, so these events never actually have a proper hit location. So if we go to Hitbox Actor BP, and we'll go to the event graph. This is what the event graph looks like and has for a while now. Now we have two functions, check simple collision and check complex collision. So these are only really for me because one is the simple hurt boxes, which are the standard squares that we're using to check overlaps, and complex is the one that actually attaches to different parts of our character. Again, you do not need them both. I'm going to show support for both because it's literally the same thing. So in each of my functions, simple and complex, all I'm going to do is click into the function, and we're going to do this little bit of math here. Okay. So this is what our function normally looks like, and you will have seen this already if you've been following the series. I made two changes to this function. One, I realized we actually did not support proximity hitboxes, considering collision occurred in the past. So you can just add this hitbox type and drag both of these into an OR and then drag it into this branch. Before we were just checking if the hitbox type was strike and then saying, oh, it was strike and it's overlapping, then we know a collision occurred. But really that was incorrect. We need to check if it's proximity or strike for any of these high, mid, or lows and then drag it in. And then if it's the throw for the throw box and then drag it in. So you can update that thing quickly. And then the other thing I've changed is I've got this hit location variable that we calculate using this little bit of logic here. Just to show you, in check complex collision, I do the exact same logic. Okay, so I don't need to show you both. You can see it right there. This is the entire function for that one. I'm going to close this one. If you do decide to follow that version of hurt boxes, then you can just copy this logic we're going to put in here. So I've gone ahead and added a variable called hit location on the hitbox actor BP. It's not required that you do this, but if you do this, you can just easily pass in the hit location to the take damage function after. It's that simple. So I figured we calculate it in these functions, and then we pass it to take damage. The way you make this variable, if you click plus variable, change the type to a vector, and then call it whatever you want. Hit location is probably perfectly fine. All right. And what we need to do is figure out where the hit actually occurred on the character. It's not quite as simple as some of our other cases, though. So say you're playing, like, you know, a third-person adventure game, and you hit your opponent. Well, you hitting your opponent, say during an animation or something like that, will have a very, very specific spot on the character that it collided with, and we can grab that spot during the hit event or the overlap event or something like that and use that location. In this case, it's a little bit different. We don't hit anybody based off of our mesh. We use these hurt boxes and these hit boxes. And so the hitbox, if it collides with the hurt box, we know that a hit occurs. And we'll know which hurt box was overlapped with the hitbox. So we will know like high, mid, low, or whatever. But it's not very specific in that case. We won't know exactly which one was hit. We won't know where it was actually hit on that one. We'll just know that they overlapped. So before we get started, the strat here is basically we're going to get the location of each of them, add them together, get the absolute value, and divide it by 2 or multiply by 0.5 because it's technically faster, and set that result in. And some of you may recognize this. This is basically we're adding them together and then we're dividing by 2 or cutting it in half. So essentially we're getting the average of the 2 locations. And so the 2 components that we need the location of are the hurt box and the hitbox itself. So hitbox display is the static mesh of this hitbox. Can't see anything in the viewport, but see how I have this material on it and this cube? This is the hitbox. So hitbox display is just the static mesh component that is here to check collision against. So we have the hitbox display and we get the world location. And that's done by literally get world location. Nothing hidden here. You can choose either in this case. The one in parentheses with hitbox display will spawn hitbox display separately. But we don't need that if you just drag off of hitbox display. It's here. Whatever you want to do. The other component that we need to get the location of is the hurt box, or what we assume is the hurt box. So we have this simple hurt box array. We go into this for each loop, and it does check for all these different hurt boxes. I drag it down here, and this node right here, get world location, is the hurt box. So we're getting the world location of the hurt box and the world location of this hitbox here that we spawned and we're checking collision against. We're adding them together, and vectors add very, very simply. They add just like anything else. So you will add, if you have a location of 5 and 10, you'll have 15. 2 and 12, you'll have 14. It's very simple. So we're going to vector plus vector these 2 world locations. Literally click plus and also do vector plus vector. Don't believe we actually need this absolute value. It was kind of part of what I was doing before, but I realized if you happen to have a negative location, it's actually okay in this case. It kind of just relates to, since it is a world location, it kind of just relates to where it is in the world. So you can just keep it as this. We don't have to complicate it further. I'll move this over so it's a little bit easier to see. But this is what it should look like. All right. And now, if you set that to your hit location, and I only set it when a collision has occurred. So after we set collision occurred to be true, I set the hit location. Otherwise, it's null or empty or 000, which if somehow it were to even display the effect at that point, even though it shouldn't, then it wouldn't even be shown on screen anyway. Now this hit location has the value. So if you just literally go over to your take damage functions and pass in your hit location, so just drag it in, just like that, to both player 1 and player 2. And you're good to go. Now when we play our game, we go back into it. You'll be able to hear and see effects, sound effects and visual effects, right at where we hit our opponent. All right. And there we go, guys. So that's how you can add more effects to your characters and to your game. Pretty simple tutorial, but very, very useful. And in the next episode, we're going to finally cover render depths. So what we're going to be doing is trying to render the HUD behind the character. That one's the trickiest, so it might take a little bit more than just one episode. And we'll be rendering the hurt boxes on top of the character as opposed to in the center, as you would normally see in fighting games. And we'll also be rendering our effects on top of the character as opposed to in their center. Alright guys, that's all I got for you, so thank you so much for watching. I hope you enjoyed. If you did, please subscribe. It does more for me and the channel than anything else you can do. I just really appreciate it. I want to give a huge shout out to all my YouTube membership and Patreon supporters and subscribers. Thank you guys so much. I really appreciate it. If you guys had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. Be happy to help you out with any issues you had. And it's completely free. Alright guys, that's all I got for you. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye guys.